Hi everyone. In this chapter we will be studying linear functions. In this lesson we will be looking at the slopes of parallel and perpendicular lines.
All right, now in the last chapter there, the last lesson, we took a look at slope. We were talking about linear functions or linear graphs there, but we were looking specifically at slope. Now we want to take that idea a little bit further. We're going to talk about parallel lines, because let's think about this. Parallel lines are lines that always are the same distance apart. On flat Euclidean space, they never ever intersect. So this is your understanding at this point of parallel. This is consistent with what you've seen before. Turns out there are some variations on this idea, but for right now, we're going to be very consistent with what you've seen before. Parallel lines essentially never meet. Now bear in mind, a little bit of notation, we use this symbol to indicate when two lines are parallel. So you're seeing that right here. So AB, two vertical lines parallel to CD. AB parallel to CD. Now, what I need you to do is to make this connection. Parallel lines have the same slope. Okay? They have exactly the same slope. And it really, that does make sense. Now think about this. Line CD is below line AB. Okay? So let's say when A goes to B here, when I go over horizontally, I don't know even how much this is. Was it 1, 2, 3, 4, 5? When I go over 6 units, A drops 3. Well, in order for C to avoid bumping into the, in order for CD to avoid bumping into AB, it basically has to do the exact same thing. When I go over 6 here, it's got to drop down 2. Now, if it doesn't drop down 2, then eventually over here they're going to meet. Now, what if it drops down more than 2? Well, if it drops down more than 2, think of it like this. If from C to D it drops down more than 2, well, then eventually to the left they're going to meet somewhere. So the slopes have to be exactly the same in order for the two line segments to be parallel. Okay, so now here's a good example. This line right here to go from A to B, and this is done for us. We go up 7, we go across 5. The slope here is going to be 7/5. For CD, it's the exact same thing. So in this case here, we could write confidently that AB is parallel to CD. Okay, now there's some other notation here. I mean, I might use like line AB is parallel to line CD. But anyway, important that you understand what's going on there. Same slope. On the other hand, perpendicular lines, okay, or actually we should probably say it like this, not perpendicular slopes, but perpendicular lines are lines that meet at 90 degrees, okay, at a right angle. Okay, now, when that happens, in most examples of this, what's happening here, let's take a quick look over here. What's going on here is that one slope, for example, will be negative, one slope will be positive. So they have different signs. Additionally, it's almost opposite behavior when you think about it here. Like to go from E to F here, what have I done? I've dropped 1, 2, 3, 4, 5, 6 for going over 1, 2, 3. Now, the exact opposite of that is going to be what we're seeing with GH. We're going to go up 3. So in other words, the run of EF becomes the rise of GH, and the rise of EF essentially becomes the run of GH, but with an opposite sign. Okay? And so this is what we mean when we write down here that their slopes are the negative reciprocals of each other. Negative, okay, we throw a negative in there, it changes signs. If the slope was positive, then the negative makes the new one negative. And if it was already negative, that additional negative will make it positive. So anyway, we're changing the signs here. And then it's the reciprocal. You take that thing and you flip it. And we'll see some examples here in a second. The other way that you might think about that is if you take those two and multiply them together, you'll get -1. Okay? So just for example here, let's say that you've got one slope is 2/3. The negative reciprocal, so if this is positive 2/3, the other slope will be negative. The reciprocal would be 3/2. And now these are going to be the slopes of two perpendicular lines. When you multiply that across, you're going to get negative 6 over 6, which is just negative 1. Now, there is one notable exception to the rule that we're just setting up here, and that is if you've got a horizontal line and a vertical line. Okay, because remember, the slope of the vertical line is undefined, and the slope of the horizontal line is going to be equal to 0. Now, in essence, that it is still true that they are the negative reciprocals of each other, because if you've got a slope of 0, the reciprocal of that, if you think about that as 0 over 1, the reciprocal, negative reciprocal, is going to be undefined. Okay, so that in one sense that does work here. However, if you tried multiplying those together, well, you can't cancel 0 with 0, so you're not going to get negative 1 when you multiply. It doesn't make sense. It doesn't make sense to multiply undefined by 0. What do you get? I don't know. That is the exception. But in every other case here, that's what we mean when we talk about perpendicular. The slopes are going to be the negative reciprocals of each other. Okay, now let's take a quick look at an example here. So in this case right here, the slope of CD, okay, the slope of CD, when it gets simplified here, we get the slope of 3 over negative 4. Or if you want to think of it like this, it's going to be negative 3/4 or negative 3 over 4. So dropping down 1, 2, 3 for a run of 1, 2, 3, 4. The negative reciprocal of that is going to be positive 4 over 3. Okay? And so starting from B here, we go up 4, 1, 2, 3, 4, and over 3, 1, 2, 3, and there we are back on that line. And so, yeah, you can see that AB is in fact perpendicular. And right here, when you multiply, here's another example, when you multiply these together, you'd get negative 12 over 12, which is again equal to negative 1. You need to have these relationships memorized, okay? When we start saying parallel lines, you need to know right off the top of your head that that means same slope, and if they're perpendicular lines, you need to know that their slopes are the negative reciprocals of each other, or that the product of their slopes is negative 1. Okay, it should just be automatic to you. Okay, so to start off with your examples here, we're going to complete the table here. This really should be just like so quick and straightforward here, as long as you understand what's going on here. So for parallel slope, if the original is 2/3, the parallel is 2/3. Okay, the perpendicular will be opposite sign, so this is positive, so negative, and then reciprocate. Here, if the original slope is negative 4, the parallel one will be negative 4. Perpendicular will be opposite sign, and then we reciprocate. Now remember, 4 is 4 over 1. So this will become 1 over 4. Here, if the original slope is 5/8, the parallel slope, the slope of the parallel line is probably a better way to describe it, will be 5/8. This is positive, so the reciprocal will be negative. Or sorry, the perpendicular one will be negative, and then we were going to flip the fraction there. We get negative 8/5. Here, now here's the exception. Remember, here's that, well, not really an exception to the rule in terms of how you approach it, but this is the interesting one. If the slope is 0, parallel slope will also be 0. Now, we might change the sign here and make this negative, but it turns out that's really not necessary, because when you reciprocate 0, you're going to get undefined. Now, you don't need to worry about negative undefined, so it's undefined. So that's all we need to write there. So remember, this is a horizontal line, this will be a vertical line. If the original line has a slope of 1/2, the parallel line will have a slope of 1/2. So the perpendicular one will have a negative slope, and then it'll be the reciprocal of that, so negative 2 over 1, or just negative 2. Negative 7/8, okay? If it's the parallel, then the slope will be negative 7/8. If it's perpendicular, opposite sign, and the reciprocal. And then here, this is just so that we have some practice with this. If our slope of the original is undefined, then the slope of the parallel will also be undefined. And then perpendicular to that, well, at this point here, you should starting to get comfortable and anticipate, well, this is a vertical line, so a horizontal line is perpendicular to it, and its slope is going to be 0. And again, Negative 0, positive 0 doesn't matter. 0 doesn't have that kind of a sign issue there. Anyway, hopefully you're getting more comfortable with that pattern here, and you're going to be able to more quickly identify parallel and perpendicular slopes. All right, so in this question, we're going to decide whether or not the pairs of slopes that we're given are parallel or perpendicular. Okay? Now, for the most part, before you would jump into these things, bear in mind that you probably should simplify these things first. So, for example, when I look at AB and I get negative 3 halves, and I look at CD and I get negative 6 over 4, well, okay, that is not the simplest form of that fraction there. Both 6 and 4 have got factors of 2 in there, so there's a common factor of 2 to the numerator and denominator. If I divide that out, I get negative 3 over 2. Notice now that the slopes are identical. These are parallel. I got to do the same thing here. Okay, negative 5/6. Well, okay, that's as simple as that's going to get. But CD, 18 over 15, well, there's a common factor of 3 to the numerator and denominator. And when I divide that out, I'm going to end up with 6 over 5. Now, notice this slope here is negative, this slope here is positive. This is 5/6, this is 6/5. These are perpendicular because they're negative reciprocals of each other. And if you don't like that, by all means, negative 5/6 times 6/5, when you multiply those together, you'll get negative 30 over 30, which is just negative 1. Whoops, sorry, can't see that. So there we go, just verification that this is perpendicular. All right, well, this is an interesting question. So if two lines here have a slope of k over 3 and 4, respectively, then what's the value of k if, and we'll start with this one, the two lines are parallel? Well, okay, if the two lines are parallel, then we know that they should be the same. So k over 3 should be the same as 4. Or if you don't like that, let's make that 4 over 1. Now, what I might do in this case here is multiply. Because I'm dividing k by 3, I'll multiply everything through by 3. On the left-hand side, I'll get 3 divided by 3. That cancels. On the right-hand side, I'll get 4 times 3, which is 12. So if they're parallel, k would be 12. If they're perpendicular, I'll tell you what, let's maybe use this property right here. If they're perpendicular, then k over 3 multiplied by 4 should equal negative 1. Now, look at what this is. I've got k over 3 multiplied by 4 over 1. That really is the same as 4 times k over 3 equals negative 1. Now, in order to get k by itself, notice that I'm multiplying it by 4/3. Or maybe you haven't noticed that. Maybe that is something that you're not quite comfortable with. You should know that multiplying k by 4 and dividing it by 3 is the same as multiplying k by 4/3. Meaning that to get k by itself, I need to take and divide both sides by 4/3. So that means dividing that negative 1 by 4/3. And if that's the case, remember, dividing by a fraction is like multiplying by the reciprocal. So this will become negative 3/4. That would be the value of k that I would need to make sure that those two lines are perpendicular. All right, so this question tells us that line 1 contains the points A and B, and then line 2 contains the points C and D here. Now we're trying to figure out if A and B are perpendicular to CD. Well, what do we got to do? We got to find the slope. So we're going to find the slope of AB first, and I'll let B be my second point there. I'll use my slope formula. So y2 minus y1 over x2 minus x1. Noticing that x1 there is going to be negative 2, so I got to pay attention to that. 8 minus 2 is 6. 5 minus negative 2 is 5 plus 2, so 6/7. Good. Now I'm going to do the same thing with CD. In this case, I'll let D be my second point here. So this will be 0 minus 7. And then the denominator is going to be negative 2 minus negative 8. Okay. 0 minus 7 is going to be negative 7. Negative 2 minus negative 8 is going to be negative 2 plus 8, or 6. Oh, and now there you go. Notice that this slope is positive, this one's negative. Okay, that's a good sign. 6/7, 7/6. They are the negative reciprocals of each other, so therefore and that's what those 3 dots there mean. AB is in fact perpendicular to CD, and I might use the line notation at the top there. Line AB is perpendicular to line CD. Right, in this question we read that line 1 contains the points A and B here, and then line 2 contains the points C and D. Now, are they parallel? Well, this is very similar to the previous one that we just did. We just got to figure out what the slopes are. So again, I'm going to do the same thing with AB. I'm going to let B be 0.2. So the y-coordinate is 0, so 0 minus 4 over negative 5 minus 3. Well, 0 minus 4 is negative 4. Negative 5 minus 3 is negative 8. All right, negative 4 over negative 8. Well, notice that the negatives will cancel, and 4 over 8 really is just 1/2. So now let's take a look at the slope of points, the line segment CD. And again, I'll let D be 0.2, so 5 minus 1. Oops, in case you can't see that, 5 minus 1. And then 1 minus negative 7. Okay, well 5 minus 1 is 4. 1 minus negative 7 is 1 plus 7, or 8. And I get 1/2. So yeah, because their slopes are exactly the same, AB, okay, line AB is parallel to line CD. All right, now this next question is a little bit more complicated. Given the points P, Q, and R, we got the coordinates there, find the coordinates of point S on the y-axis. Now that's interesting. If it's on the y-axis, let's think about that. What's got to be true? If it's some point here along the y-axis, well, if that's the case, then I know that the x-coordinate is 0. I don't know what the y-coordinate is, so I'll leave that as y, but here are the coordinates of S, 0, y. And we want this to be the case that RS is parallel to PQ. Now, the first thing we're going to do is figure out what the slope of PQ is, because parallel means same slope, and we have both points PQ, so I can figure this one out. And I'll let Q be the second point here, so 1 minus negative 5 over negative 2 minus 2. 1 minus negative 5 is 1 plus 5, or 6. Negative 2 minus 2 is negative 4. I don't really like the negative down there, so I'm going to bring the negative. I'll bring the negative up to the top. And notice that these are both even numbers, so I can divide them both by 2. So I get a slope of negative 3 over 2. RS, okay, the slope of RS. Now, bearing in mind what S is, now I'm going to let S be the second point here. So I've got Y minus the y-coordinate of R, so y minus negative 1 over 0 minus 2. So y minus negative 1 is the same as y plus 1, and then 0 minus 2 is going to be negative 2. Now, in order for these to be parallel, those two slopes here have to be the same. So I know that negative 3 over 2 has got to equal y plus 1 over negative 2. Now, I might be tempted to play with these things a little bit, like move the negative down, set the two fractions, like because the fractions would then be equal, the denominators would be equal. I can set the numerators equal. Or I can just do that little thing that I showed you before, that little cross multiplying, because I've got fraction equals fraction. Okay, that is a proportion. That's all I need. So I know that negative 3 times negative 2, which would be positive 6, has to be the same as 2 times y plus 1. So 6 is going to equal 2y plus 2 when I distribute that 2 through. Now I'll bring the 2 over. 4 is equal to 2y, and then I'll divide to get that y is equal to 2. So that means the point S was the point 0, 2. Okay, now this question says that the line segment has coordinates C and D, okay, those 2 points on there. And then we've got the point P on the x-axis. Okay, now if it's on the x-axis, remember what that means. Any point along there has got a y-coordinate of 0. Don't know what the x-coordinate is, I'll just put an x there, but the y-coordinate will be 0. So that right there, that's the set of coordinates for point P. So now what we're supposed to do here is we're supposed to figure out what P is, assuming that PC is perpendicular to CD. Okay, well, notice that I'm using point P. I'm going to figure out what the slope of point CD is first because I've got both of those points. And I'll let D be the second point there. So it'll be 5 minus 2 over 8 minus 6. Okay, well 5 minus 2 is going to be 3, and 8 minus 6 is 2. There we go. The slope of PC, a little bit more difficult to figure out because we got the point PC here is x comma 0. I'll let that be in the way they got it written here, PC, I'll let that be the second point here. So this will be 2 minus 0 over 6 minus x. So 2 over 6 minus x. Now, I know that these two slopes are not equal to each other. They're not parallel lines. I can't just set them equal to each other. That assumes that they're parallel. I know that they're perpendicular, which means that they're equal to the negative reciprocal of each other. Or their product is equal to -1. Now, that's a property that I haven't made too much use of. Let's do it right now. So 3 over 2 times 2 over 6 minus x is supposed to equal -1. Now, that means, well, okay, notice here that's 3 times 2 over 2 times 6 minus x. Those 2's are going to cancel. So this is 3 over 6 minus x has got to equal -1. Now, I can see this as -1 over 1, and so what I could do here essentially is cross multiply. 3 times 1 will equal -1 times 6 minus x, and when I distribute that -1 through, I'll get 3 is equal to, I'm going to make that x minus 6. Just notice when I multiply the negative through how that affects the signs here. And then to satisfy this part of the equation, or this level here, I'm going to add 6 to both sides, and so x is equal to 9. So therefore, I know that point P is going to be the point 9, 0. All right, this next question, this is a classic. This always shows up somewhere in an assignment or on an exam. You've got a triangle, it's got the vertices A, B, C. We want to determine whether it's a right angle triangle. This question right here does a wonderful, wonderful job of letting me know as the teacher whether or not you've really understood what's going on here. To have a right angle triangle, bear in mind that what that means is that there's two line segments must be perpendicular to each other. See, oftentimes I've bumped into students that haven't made that connection yet. That in a right angle triangle, okay, if you've got a right angle triangle like this, let's say, they know that this is a right angle, but they haven't really put it together that means that those two lines are perpendicular. So that's what's going on here. So what we need to do ultimately is start to find the slopes of the different line segments, and what we're looking for is a pair of slopes that are the negative reciprocals of each other, because if that exists here, then we've got two lines that are perpendicular, meaning that this has got to be a right triangle. So let's figure out the slope of AB. Now let B be the point 2. So -2 minus 3 over 8 minus -2. Got to be careful about that negative in there. So -2 minus 3 is going to be -5. 8 minus -2 is going to be 10, because that'll be 8 plus 2. And remember, you want to reduce these things. You don't want to just leave them like that. So this is going to be -1/2. And now I'll find the slope from, let's say, A to C. Okay, well now I'll let C be the second point. So this will be 6 minus 3 over 4 minus -2. Okay, well 6 minus 3 is going to be 3. 4 minus -2 is going to be 6. And when I reduce that, I get 1/2. Okay, well they're opposite signs, but one is not the reciprocal of the other, so at this point I don't know. So I've got to go one step further. I have to figure out the slope of point BC. And in this case, just like before, I'll let C be the second point. So 6 minus -2 over 4 minus 8. 6 minus 2 is going to be 8. 4 minus 8 is going to be -4. And when I reduce that, I get -2. And now take a look at this. Notice that line segment AC, line segment BC, they have opposite signs, and 1 over 2 is the reciprocal of 2 over 1. So yes, this is a right triangle. This, okay, not this, this is a right triangle. Okay, and the 90-degree angle is at vertex or point C. And I know that because notice that I determined that these were the two line segments that were perpendicular, and C was common to both of those. So that's got to be where that right angle is sitting.